नमस्कार दोस्तों, मेरा नाम शशिकांत है। आपका चैनल पे स्वागत है। ये चैनल सिविल इंजीनियरिंग इंटरव्यू क्वेश्चंस और आंसर्स के लिए डेडिकेटेड है। आज हम आपको कुछ इंपॉर्टेंट टिप्स और ट्रिक्स देंगे जो आपके इंटरव्यू प्रिपरेशन में मददगार साबित होंगे। अगर आपको हमारा कंटेंट पसंद आए तो प्लीज लाइक, शेयर और सब्सक्राइब करना ना भूलें। चलिए शुरू करते हैं। Question 9. Procedure of construction of well foundation. ANSWER site preparation and survey. Fabrication of the well curb. Construction of the well steining, cylindrical wall. Sinking process. Devating. Adding concrete blocks for additional weight. Cutting edge management. Finalizing the sinking. Backfilling and grouting. Superstructure integration. Final inspection and maintenance. Question 10. How to check tilt and shift? Answer: shift. When the well is moved away horizontally from the desired position, it is called shifting of well foundation. The shift in well foundation should not be greater than 1% of the sunk depth, beyond which the well foundation is considered as dangerously unstable. Tilt. When the wall has sloped vertically, it is called tilting. The maximum tilt allowed in well foundations is 1 in 60, beyond which the well foundation is considered as dangerously unstable. To rectify the tilt, the well is loaded eccentrically against the direction of tilt and cartilage method is applied during further sinking of the well. Question 11. What type of tests on pile? Answer: as there are so many pile tests available depending on its purpose, but the most common type of pile tests are the dynamic load test, static load test, and the pile integrity test. Dynamic load test. The dynamic load test is conducted to assess the behavior of piles under dynamic loads. It helps determine the pile's capacity, stiffness, and response to dynamic forces. The test involves striking the pile head with a heavy hammer. Common hammer weights range from 5 kN, 500 kg, to 30 kN, 3000 kg, or more. The choice of hammer weight depends on the project requirements and pile type. Typically, 10 to 20 blows are applied during each test increment. The allowable settlement is limited to 3 to 4 mm per blow of the hammer. If the pile settles excessively, it may not meet design requirements. Output parameters for dynamic load test on piles. 1. Bearing capacity and skin friction. 2. Distribution pattern of skin friction. 3. Compressive stresses. 4. Displacement of the test pile. 5. Pile integrity. Static load test. In a static load test, a heavy constant dead load, often called cartilage, is applied to the top of the pile. The pile's behavior is closely monitored during loading. The test load is incrementally increased until either the pile settles excessively or reaches the required capacity. Settlement is measured at specific time intervals, e.g., hourly, during the test. The test duration varies but typically lasts 24 hours or more. Common limits include: 1. Immediate settlement, typically limited to 10 to 25 mm for safety. 2. Total settlement, usually limited to 50 to 100 mm, depending on the structure's sensitivity. 3. Rate of settlement. Settlement should not exceed a certain rate, e.g., 0.25 mmr. Output parameters for static load test on piles. 1. Ultimate load capacity. 2. Load settlement relationship. 3. Settlement at working loads. 4. Safety factors and margins. Pile integrity test. 1. Surface preparation. Smoothen the pile head at a minimum of 3 locations in an equally divided quadrant of the entire pile circular cross-section. All piles should be at the cutoff level. 2. Sensor placement. Place the accelerometer on the pile head surface. Ensure proper contact between the accelerometer and the pile head. 3. Hammer blow. Apply a gentle hammer blow, not necessarily a hard one, to the pile head. The gap between the hammer impact point and the sensor should be 300 mm in each quadrant of the pile cross section. 4. Data collection. Record the test data appropriately. Mention the weight of the hammer used in the test in the report. 5. Interpretation. Analyze the test results using PW software. Evaluate the integrity of the pile based on the recorded data. Question 12. Routine load test on pile. Selection of piles for the routine test is done based on number of piles required subject to maximum of % of total number of piles required. The number of tests may be increased to 2% depending on the nature type of structure. The test load applied is 1.5 times the safe carrying capacity of the pile. Routine tests ensure the safe load capacity of piles and detect any unusual performance contrary to initial test findings. These tests are conducted at the cutoff level, and a detailed report is prepared for the test results. Question 13. Pile load test. Answer. This test is used to determine the load carrying capacity of a pile. This test gives us the value of ultimate load value, safe load value, settlement under different values of load. Equipments used: test beam, steel plate, test plate, hydraulic jack, test pile, dial gauges. Question 14. What do you mean by development length? Answer. The development length is the length of reinforcement bar required to be either embedded or projected into the column to achieve the desired bond strength between the concrete and steel or any two types of materials. Development length is necessitated due to it ensures a secure bond between the bar surface and concrete to prevent slippage failures under ultimate load conditions. At critical points like column beam junctions, the additional length of bars facilitates effective stress transfer and enhances structural integrity. As per 456/2000, the minimum development length in a column is 24 to 55 d. Question 15. What do you mean by lap length? Answer. Lap length, in reinforced concrete construction, refers to the length of overlap provided in a reinforcement bar, rebar, where two separate sections of the bar are connected, and in order to safely transfer the load from one bar to another bar. The relation between development length and lap length, ACC. To IS 456/2000 for flexural tension, lap length LD, development length, or 30d, diameter of bar, whichever is greater is considered. Flexural tension refers to the tensile stress experienced by a material when it undergoes bending or flexure. For direct tension, lap length to LD, development length, or 30d, diameter of bar, whichever is greater is considered. Direct tension occurs when a material is subjected to a direct pulling force along its axis. Question 16. What do you mean by scour depth? Answer. Scour is a natural phenomenon of lowering the riverbed level due to removal of sediment by the erosive action of flowing stream. The magnitude of reduction in the riverbed level below an assumed natural level, or initial level, is termed scour depth. Methods of calculating scour depth. Empirical equation. Empirical equations are widely employed during the design stage to estimate the maximum scour depth. 2. These equations are based on observed data and historical scour patterns. 3. They consider factors such as flow velocity, sediment characteristics, and pier geometry. Laboratory experiments. 1. Physical model experiments in laboratories help simulate scour conditions. 2. Researchers study the scour depth by varying flow rates, sediment sizes, and pier shapes. 3. These experiments provide valuable data for developing empirical equations. 4. Numerical modeling. 1. Computational models, such as 2D or 3D hydrodynamic models, simulate flow patterns around bridge piers. 2. Numerical simulations predict scour depth based on hydraulic parameters and sediment transport. 3. These models account for complex flow interactions and sediment dynamics. 4. Numerical modeling. 1. Computational models, such as 2D or 3D hydrodynamic models, simulate flow patterns around bridge piers. 2. Numerical simulations predict scour depth based on hydraulic parameters and sediment transport. 3. These models account for complex flow interactions and sediment dynamics. 5. Field observations. 1. Field studies involve monitoring actual bridge piers during flood events. 2. Researchers measure scour depth under real-world conditions. 3. Field data contribute to refining empirical equations and validating models. 5. Field observations. 1. Field studies involve monitoring actual bridge piers during flood events. 2. Researchers measure scour depth under real-world conditions. 3. Field data contribute to refining empirical equations and validating models. Question 17. What is silt factor, KSF? Answer. The subsoil strata is represented by a numerical value called the silt factor. This factor plays a vital role as the foundation level depends upon soil strata underneath, which is examined based on the bore log data. It indicates the type of bed material from clay to heavy sand. Foundation level is fixed below the scour level after considering the grip length. Question 18. Types of bearing to be used. Answer. Bridge bearings are structural equipment installed between bridge substructure and superstructure to transfer the applied load, including earthquake loads, wind loads, traffic loads, and superstructure self-weight. Bridge bearings also makes rooms for relative movements between superstructure and substructure, for instance, rotation movements and translational movements in horizontal and transverse direction. Different types of bearings for bridges include sliding bearings, dot rocker and pin bearings, roller bearings, elastomeric bearings, curved bearings, pot bearings. Question B. Detailed procedure for pre-stressing. Pre-stressing. Answer. Pre-stressing is a technique used in construction to increase the strength and durability of concrete structures by applying stress to the reinforcement before the concrete is poured. This process helps counteract the tensile forces that concrete is weak against, ensuring that the structure can withstand heavy loads and resist cracking. Pre-stressing is the creation of permanent internal stresses in a structure or system to improve its performance by counteract the stresses induced by external loading. Precast elements may be pre-stressed during the construction process, pre-tensioning, or structures may be stressed once completed, post-tensioning. In pre-tensioning, steel wires are tensioned before concrete is placed and hardened. In post-tensioning, steel wires are stretched out once the concrete is settled and hardened. The tendon is inserted into the duct, anchored on one side and pre-stressed by stressing jack on the other side, or it can be stressed in 2 steps from both sides. नमस्कार दोस्तों, मेरा नाम शशिकांत है। आपका चैनल पे स्वागत है। ये चैनल सिविल इंजीनियरिंग इंटरव्यू क्वेश्चंस और आंसर्स के लिए डेडिकेटेड है। आज हम आपको कुछ इंपॉर्टेंट टिप्स और ट्रिक्स देंगे जो आपके इंटरव्यू प्रिपरेशन में मददगार साबित होंगे। अगर आपको हमारा कंटेंट पसंद आए तो प्लीज लाइक, शेयर और सब्सक्राइब करना ना भूलें। चलिए शुरू करते हैं।